Namaskar, I am Biju Dharmapalan and you are watching Science Time, a show that brings you the latest developments from the world of science and technology. Let's first look at some of the exciting stories. Scientists developed a new aqueous electrolyte that can help in the electrochemical synthesis of ammonia. Scientists developed a cool new method of refrigeration. Eating too much salt could be making you stressed. Now let us see the news in detail. Indian scientists have discovered a new aqueous electrolyte that can help in the electrochemical synthesis of ammonia. Electrochemical ammonia synthesis is largely limited by the poor solubility of nitrogen in an aqueous electrolyte environment as well as the competitive hydrogen evolution reaction. The obstacle faced was the reduction of nitrogen in the aqueous medium. Now, scientists from the Institute of Nanoscience and Technology at Mohali, an autonomous institute of the Department of Science and Technology, have introduced a new electrolyte called sodium tetrafluoroborate, which not only acts as a nitrogen carrier in the medium but also works as a full-fledged co-catalyst along with active material transition metal doped nanocarbon to deliver high-yield ammonia at absolutely ambient experimental conditions. The high production rate of ammonia approached the industrial scale and exceeded almost all the standard catalysts in any other electrolyte medium. The source of ammonia was thoroughly studied and confirmed to be chiefly from the electrochemical reduction of the purged nitrogen gas. This research is published in the journal Proceedings of National Academy of Sciences, and it is a novel approach to get through the long-standing issues about the solubility of nitrogen in aqueous medium and achieve industrial scale production of ammonia by nitrogen reduction reaction at ambient condition. Now let's see the next story. Refrigeration methods have significantly impacted various industries, revolutionizing everything from food preservation techniques in the home and industry to provide a safe chilled environment for storing samples, reagents, blood, plasma, enzymes, cell cultures, and patient medication in the laboratory. Yet, the conventional refrigeration techniques use gaseous mixtures and consume high levels of energy that can pose a risk to the environment, contributing to global warming. Adding salt to a road before a winter storm changes when the ice will form. Researchers at the Department of Energy's Lawrence Berkeley National Laboratory have applied this basic concept to develop a new method of heating and cooling. The technique, which they called Caloric Cooling, is described in the paper published in the journal Science. Caloric Cooling takes advantage of how energy or heat is stored or released when a material changes phase, such as changing from solid ice to liquid water. Melting a material absorbs heat from the surroundings, while solidifying it releases heat. The ionocaloric cycle causes this phase and temperature change through the flow of ions or electrically charged atoms or molecules which come from a salt. Researchers hope that this method could one day provide efficient heating and cooling, which accounts for more than half of the energy used in homes and help phase out current vapor compression systems which use gases with high global warming potential as refrigerants. Ionocaloric refrigeration would eliminate the risk of such gases escaping into the atmosphere by replacing them with solid and liquid components. Now let's move to the next story. According to a recent study published in the journal Cardiovascular Research, A diet high in salt can contribute to stress. In experiments with mice, researchers discovered that a high salt diet led to a 75% increase in stress hormone levels. These findings may prompt a review of public health policies related to salt intake, with the goal of reducing the amount of salt used in processed foods. It is recommended that adults consume no more than 6 grams of salt per day, but most people consume around 9 grams on a regular basis. This can contribute to higher blood pressure, which increases the risk of heart attacks, strokes, and vascular dementia. While effects on the heart and circulatory system have been well established, little was known about the impact of high salt diet on a person's behavior. To study this, experts from the University of Edinburgh used mice who ordinarily have a low salt diet and gave them high salt food to reflect the typical intake of humans. They found that not only did the resting stress hormone levels increase, but the mice hormone response to environmental stress was double than that of mice that had a normal diet. Salt intake increases the activity of genes that produce the proteins in the brain, which control how the body responds to stress. Experts say further studies are already underway to understand if a high salt intake leads to other behavioral changes such as anxiety and aggression. Now let's move to Science Quest segment. The question for this week's Science Quest is, what is Maillard reaction? Often described as non-enzymatic browning, the Maillard reaction gives a wide range of cooked foods their appealing flavors and colors. Sped along by heat, the Maillard reaction is actually a series of reactions starting with one between protein and reducing sugar, such as glucose or fructose. The reactions produce flavor chemicals and browning in foods, including fried onions, toast, steak, and roasted coffee. French chemist Louis Camille Maillard first reported the reaction between proteins and sugars in 1912. In recent decades, scientists have unearthed more of Maillard detailed mechanisms. When the heat hits food, sugars react with the amino acids that make up proteins to form glucosamine. This unstable chemical rearranges to create a ketosamine, setting off a cascade of further reactions to produce hundreds of new substances, some of which contribute to flavor and aroma. These include pyrazines, which have a toasted flavor, along with meaty furans and sweet furanones. Finally, the reaction creates large polymer molecules called melanodins, which give a brown color. In order to obtain Maillard products in a short time, the temperature should exceed 100 degrees Celsius with an ideal range between 110 degrees Celsius and 170 degrees Celsius. If the temperature is too high, then bitter flavors can develop. A downside of Maillard reaction is that it creates a carcinogen called acrylamide as a byproduct. Levels of this increase with longer cooking times. With this, we come to the end of this edition of Science Time. Keep sending your feedback and suggestions through email. Our email ID is indiascience@vigyanprasad.gov.in. We will be back with more exciting stories from the world of science next week. Stay tuned to India Science.